In this video, we're going to talk about Taylor and McClaurin series. The idea at a certain cases, you can't do this all the time. The idea is you can write the function f of x in terms of infinite of other function. And basically, the formula you need to know is f of a plus first derivative of a, x minus a over 1 factorial plus second derivative of a, x minus a squared over 2 factorial and so on. And to express that, we need to write summation of n of a, x minus a raised to n over n factorial. So let's proceed to the problem. We're gonna find the McClaurin series. The only difference of McClaurin and Taylor series is that the center of McClaurin is always 0. So we have this equation, f of x is equals to e raised to 5x. The step 1 is getting the derivatives of the equation of f of x. So we have f of x equals to e raised to 5x. The first derivative is 5e 5x. The second derivative is 5 squared e 5x. You could write directly 25 in here, but I recommend not to multiply all these things out to see the pattern. So let's proceed. The third derivative is 5 raised to 3 e raised to 5x. And then in general, I will write n of x is equals to 5 raised to n e 5x. We're going to use this equation to fill up the McClaurin series formula. Then let's proceed to step 2. We will going to substitute 0 to the function of x. So f0 is equals to e 5 times 0. So the answer will be 1. The first derivative is 5. The answer will be 5. On the second derivative, the answer will be 5 squared. In third derivative, the answer will be 5 raised to 3. Eventually, my assumption in nth derivative is f of n, which is 0, is equals to 5 raised to n. So now we can actually write e raised to 5x is equals to 1 plus 5 times x minus a, which is 0, over 1 factorial plus 5 squared x times x minus 0 over 2 factorial plus 5 raised to 3 x minus 0 over 3 factorial and so on. By just looking to the equation we got, we will come up with this answer, which is summation of 5n x raised to n over n factorial. And that is the McClaurin series. So for the second example, we have this equation and we're gonna find the Taylor series. So again, the first thing I'm going to do is write down the original equation, which is f of x is equals to ln x. and I'll start getting the derivative. The first derivative of ln x is equals to 1 over x, but I will write down simply x raised to negative 1. Then the second derivative is negative 1 x raised to negative 2. The third derivative is positive 2x raised to negative 3. Fourth derivative is negative 3 point or times 2 x raised to negative 4. So in this situation, I won't going to multiply all the things out just like what I did a while ago. And then the fifth derivative is equals to 4 times 3 times 2 x raised to 5. The sixth derivative is negative 5 times 4 times 3 times 2 x raised to negative 6. And the reason why I'm not multiplying all these things, look what we got. Negative 5 times 4 times 3 times 2 x raised to negative 6. We can write more compactly using the factorial notation. Alright, so we're gonna go back and we're going to start calculating our derivatives to our original function to value a is equals to 2. So, by substituting ln 2, so the first derivative is 1/2. Second derivative is negative 1 times 1/2 raised to 2. The third is 2 times 1/3 raised to 3. And so on. Until we got the sixth derivative, which is equals to negative 5 factorial times 1/2 raised to 6. So now we can see that we have nice relationship with this equation. So we now actually write ln x is equals to ln 2 plus we have 1/2 times x minus 2 raised to 1 over 1 factorial plus negative 1 times 1/2 squared times x minus 2 raised to 2 over 2 factorial plus 2 times 1/2 times x minus 2 raised to 3 over 3 factorial until negative 5 factorial times 1/2 raised to 6 times x minus 2 raised to 6 over 6 factorial. It seems like ln 2 plus summation, and the sign is alternating, so we include negative 1. You will notice the exponents are positive, so we will add n plus 1. And after that, we also add 1/2 raised to n, because 1/2 always appears in every term, and then simply x minus 2 raised to n over n factorial. N minus 1 factorial, because we will not forget this negative 5 factorial. So, a little tricky here. I'm gonna rewrite to clean it up. So we will end up ln 2 plus summation negative 1 raised to n plus 1 times x minus 2 raised to n over 2 raised to n minus n. And so that's how Taylor series is. Thank you.